we're going to try another operator in here. Move the camera back a little bit and zoom out a little so we get a better view. We're going to try a magnet operator. So this is designed to behave similarly to the magnet SOP. So what this does is it takes some point in space set by this center parameter here, and then the closer that things are to that point, the more of a transformation is applied to them. So here we're going to try something like, say, decreasing the scale, which is going to kind of shrink things in towards that center point. So by default, that amount of transformation is off. So as we increase that, you can see that it's pulling things in certain areas. So if we increase the radius there, so you can see like it will apply that amount within that distance of wherever your center point is. So you move it around there. Just to kind of keep things a little bit easier to understand for now, I'm going to switch off this modulo so we just have a single copy here to look at. So this is another case where hard edges can kind of lead to these discontinuities or can cause some rendering issues. So if you zoom in here, you can see like the points where that radius, the hard edge hits, things get a little messed up in the rendering. So solution to that for magnet is this fade one, fade parameter, which will kind of smooth out that edge. So you can see as we move that magnet point around, the points where, so it's got that center area where within the radius where it kind of applies the full effect. And then for some distance outside of that, it will blend that effect with no effect. And you can play around with, so it's got scale, which will kind of shrink or expand. And it will do that like towards the center of whatever that point is. Or you can do rotation, and that will kind of spin things around. So again, notice that like if you push things a little bit too far, then you can get these kind of rendering errors. So you kind of need to tune your parameters and make sure that you're staying within like a safe range. All right, so we're going to try another filter. So we're going to go with a twist filter. So just going to replace the magnet with that. All right. So twist is supposed to behave a lot like the twist SOP. You specify an axis that it operates along, and then an amount of twisting that applies. So here, we're going to switch this to the y-axis. This will kind of twist space around that axis. So you can get some really neat effects with this. Noting again that if you push things, really far, then the rendering can get a little bit strange. So again, you have to kind of find a reasonable range for the parameter. So bring this down to something like that. All right, and see what that looks like with this modulo on top of it. So that's kind of neat. And yeah, hit play and you can watch that effect on the combine operator sort of being applied before all the twisting and the repetition. Right, so we're going to create another filter here. This time we're going to use an Iterated Transform. So we're going to stick that in here after the twist for the modulo. So you'll notice that a lot of the parameters here look similar to the transform. So I'm just going to switch off the twist just to make things a little bit easier to see. Okay. and we're going to switch off reflect there. Okay. So on its own, this isn't going to do anything. But if you enable some of these different kinds of transformations, you'll notice that this right now is just behaving like the regular transform does. But where things get interesting is if you start using the reflect modes. So we're going to switch this down to 1. We're going to go to reflect along the y-axis. So you can see there it kind of mirrored space along that axis. And if you want to do that just on its own, there is an op called reflect that will just do that reflecting space thing. So here it's kind of part of a larger system. So stick that down. All right, so we're going to change this number of iterations back up to, say, 3. And then we're going to start playing with rotation along the z-axis. Okay. So here you can see it's kind of, it looks like it's rotating and then it's reflecting. But where things get interesting is in spots like around here. So what this is doing is it is applying a transform. So it's doing that little rotating by 12 degrees along the z-axis. Then it's reflecting space along y, which gives it that kind of cut point. And then it's doing that again, rotating by another 12 degrees and reflecting again. And then it's doing that 3 times currently. So that will produce some really interesting effects. So this is basically what's known as an iterated function fractal, and it will produce some really interesting effects. You can try like a different mode, like reflecting along both x and y, and you'll get these shapes that will kind of pop in and out of existence, and you can play around with different kinds of transformations and see what you can get out of this. There is a lot of capability built into this one op. So you can try something like translate, which will kind of shift things. It's useful to just kind of try things and see how it behaves. So for translate, it kind of makes sense. It's like shifting it, and then before it rotates and cuts it, rotate. It spins around. But some combinations of those things can produce some pretty unexpected results sometimes. So try a different reflect mode, like on all 3 axes here, and get some shapes like that. Gonna bump the camera in a little close. I'll change the view angle, zoom in a little bit, and we're then going to just kind of experiment with some of those options there. So you can also increase the number of iterations. So let's reset that. So this will perform. It'll changes how many times it performs that operation. So here it's rotating around the x-axis and it's cutting space and then rotating again. It's doing that 7 times. And you can get some really interesting fractal shapes just by messing around with the transformations on there. When you're dealing with operators like this, where it's kind of cutting space and reflecting it, you can sometimes end up in situations where you have kind of hidden all of the actual shapes, so things will kind of pop out of existence like that. So as you are playing around with parameters, you need to find the combinations that will cause that problem, combinations that are safe. This can be a little bit of a tricky thing during live performance. So if you want to kind of have a range of parameters that you can safely play around with during like a show, it's good to kind of figure out what those safe ranges are and, maybe put some like limitations in place to kind of prevent it from popping out of view of the camera or something. But if you're just playing around with it, it's great. You can try all kinds of different combinations there and get some pretty interesting shapes. And just to kind of see that in action, we're going to copy this chain of chops here. I'm going to rename this, R, and X, and then stick that chop into, say, like the X rotation here, and then increase this up. So you'll notice that the rotation here, like other touch operators, is done in terms of degrees, so 0 to 360. Internally, you'll see a lot of shader stuff will work off of radians, but the goal here is kind of provide a similar interface to what Touch natively provides. And so we change kind of what axes it's reflecting along. Maybe just do like X and Y. So this will just kind of spin infinitely. And if you increase the number of iterations, you can get some more patterns like that. Just see what it looks like. Let's stick on modulo 1D. All right. So you'll notice that there are combinations of operators that can produce kind of a reduced frame rate. So you can see here this kind of dropped down to like around 30 FPS. And so some things that you can do to improve that is kind of like decrease iterations, that kind of improve things a bit there. So it's doing a little bit less work in that operator. There are some render settings that you can play around with. So you can say like reduce the resolution to 1280 by 720, which you can also use if you're using a non-commercial license of TouchDesigner. Anti-aliasing will definitely improve render quality, but it involves doing a lot more work. So you'll see that can have a pretty significant impact on performance. So you can see it's chugging along at 20 frames a second. This is on an RTX 2080. So you can see that things can get pretty costly depending on what operators you have. So generally, if you're just playing around with things and not doing like a non-real-time render, you can usually bump the anti-aliasing down to 1. That'll improve performance quite a bit, and 1 is the default there. But you will sometimes end up with some kind of like staticky bits around edges there, which is something to keep in mind, especially if you're doing like a higher quality rendering. You usually want to like switch that anti-aliasing back up.